Hello dear students, this is Lazaro Pino, your chemistry professor, and we are presenting today organic chemistry. In special, we are going on over the naming and recognizing the different functional groups in organic chemistry. Let's begin by the alkanes. Which one are the alkanes? Are those one who has between atom of carbon single bonds. These are the alkanes, and they have a prefix that indicate the number of atoms of carbon. For example, for one atom of carbon is methane, for two atoms of carbon is ethane, for three propane, for four butane, for five pentane, and so on until 10, that is decane. The ending will be always -ane. What changes is the prefix that is according with the number of atoms of carbon. Here you have the general formula or molecular formula for all the compounds from 1 to 10 atoms of carbon in the group of the alkanes. In the right, you can see, for example, methane. Methane has 4 atoms of carbon. Every time you have to count the number of atoms of bonds that carbon has. If it is not 4, it's because something is going wrong. This is the structural formula, and this is the half structural formula. In this case, you have ethane. Ethane has 2 atoms of carbon, a single bond between, and you can see that every atom of carbon has 4 bonds. Here you have the structural formula. Also, this formula is known as condensed. The alkanes are characterized by a single bond, but also we have the alkenes that has a double bond and the alkynes that has a triple bond. These compounds are aliphatic because they have long chains, but in the other hand we have the aromatic hydrocarbons. The most characteristic one is benzene that has 6 atoms of carbon, and between one atom of carbon and another there is a single bond, then a double, a single, a double, a single, and a double. And this compound is very important for the pharmacology because it's the source or is present in most of the medicine that we have nowadays. Another way to represent the aliphatic the organic compounds is by zigzag lines. Every line here represents an atom of carbon. This is butane because it has 1, 2, 3, and 4 atoms of carbon. This is pentane, 1, 2, 3, 4, 5 atoms of carbon, and here no name with 9 atoms of carbon. Also, we have the straight, but also we have the branched alkanes, where you have branches of alkanes in the sides, and the cyclic alkanes. For example, this one that has 1, 2, 3, 4, 5, 6, 7 is cycloheptane. This that has 6, cyclohexane, cyclopentane, cyclobutane, and cyclopropane. Let's see how to name compounds that have side chains. As you can see here, you have the rules. You name the long. First of all, you have to find the longest chain. Which one is the longest chain in this case? Well, here 1, 2, 3, 4, 5, 6, 7 atoms of carbon. Then this is heptane. And if you begin numbering by the closer substituent, you say 1, 2, 3, 4, 5, 6, 7. You have and in carbon 3 you have an ethyl group. Then it will be 3 dash ethyl dash 2,3 dash dimethyl heptane. That's the name of this compound. Let me go slowly this time. You begin naming alphabetically. The first substituent is ethyl, that begins with E. Is in carbon 4. Then you say 4 ethyl, 2,3 dimethyl, and then the longest chain, heptane. In the case of the alkenes, you have a double bond between atoms of carbon. But this is ethene because it has 2 atoms of carbon. Then the prefix is eth, and the ending is "ene" because it's an alkene with double bond. This is propene because you have 1, 2, 3 atoms of carbon. Then the prefix is prop, and the ending is "ene" because it's an alkene. But you have to be careful because this, even though is butene because it has 4 atoms of carbon, this has the methyl groups in the same side of the chain, while this one that is also butene has the methyl group in opposite position. That's why this is 6,2-butene, and I say 2 because the double bond is in carbon 2, 6,2-butene, and this is trans 2-butene. These two compounds are known as isomers. They have the same general formula but different disposition in the space. The other group of compounds that we are going to study are the alcohols and the ethers. Alcohols contain an OH group, while ethers have an oxygen between 2 atoms of carbon. In this case is 1-butanol, 1, 2, 3, 4 atoms of carbon, and the alcohol group is in carbon 1. That's why we say 1-but because of the 4 atoms of carbon, and ol because it's an alcohol. Here you have, for example, this one is propanol, 3 atoms of carbon and the alcohol group, but this is also propanol, but the alcohol group is in carbon 2. Then this is 2-propanol, while this one is 1-propanol. The ethers are named according with the alkyl groups they have in every side of the oxygen. This is an ethyl group, and this is also an ethyl group. Then you have to say diethyl, and the last name is ether. They are used as anesthetic, while the alcohols are used as a disinfectant. Okay, here we have the carbonyl group that is made by a carbon with a double bond with oxygen. If one side of this chain you have a hydrogen and in the other a group of carbon, you are in front of an aldehyde. But if both sides of a double bond with the carbon with the oxygen you have carbon both sides, you are in front of a ketone. Here, for example, you have methanal. Meth because it's only 1 atom of carbon, and al because it's an aldehyde. Ethanal, 2 atoms of carbon, eth, and al because it's an aldehyde. Propanal, and 2-methyl because you have a methyl group in carbon 2, 2-methyl butanol. In this case, it's a ketone. The ketone has the methyl groups or alkyl groups in both sides of the carbonyl group. This is propanone. Prop because of the 3 atoms of carbon, and on because it's a ketone. If you have a group like this where you have a carbon with a double bond with oxygen, but in the other hand you have an OH group, you are not in front of an alcohol. This is a characteristic group of the carboxylic acid. If in one side, instead of having the hydrogen characteristic of the acids, you have a carbonyl group, then this is an ester. For example, here you have the reaction between a carboxylic acid and an alcohol produce an ester. Esters are very important because the aromas and flavors of many of the fruits are two esters. Carboxylic acid has the same characteristic of the acid that we study in inorganic chemistry, but they are almost always weak acids. The following group of compounds that we are going to study is the one that instead of having the OH group of the carboxylic acid, they have a nitrogen group. This is an amide. For example, in this case, you have ethano methyl amide, because you have a methyl group in here. Amides are very important in biology. The last group we are going to study comes from ammonia. You remember that ammonia is a nitrogen with 3 hydrogen. But if instead of having 1 hydrogen you have a methyl group, you are in front of methylamine. If you have 2 atoms, 2 methyl groups, then you have dimethylamine. If you have 3, it's dimethylamine. In this case I am using methyl, but it could be ethyl, propyl, or other alkyl group. Amines are very important because many of the neurotransmitters like dopamine are amines. Well, that's all for today, and I hope you have understand what we have seen.